So guys, today topic is also important, which is high availability. So you can say that how F5 can be configured on high availability. So that is what we will be covering today. Or you can say it's also called device service clustering. So you can say cluster of two F5 devices or three F5 devices. So that is called device service clustering. So in high availability, so what would be the things we need to take care? We will understand that. First of all, what is high availability? Then we will cover what are the configuration steps which is needed for high availability. Then we will see how to config sync. Like if I do changes on one device, it should be migrated to another automatically. So we will cover all this step today. And what are the consideration, what are the best practice to configure F5 devices in HA. So let's start with the concept of high availability. So high availability in F5 is called device service clustering. So it is a combination of two or more physical F5 devices. First of all, you need to take care of this thing. So it is a combination of two or more physical devices. Suppose I have client, then I have internet, then I have F5. Generally, this is our use case without HA. In that case, this is called stand-alone box. But why I need to configure device service clustering? So device service clustering, or you can say high availability, it's also called in internet, you will see it's called DSC. So in this requirement is to configure high availability so that my traffic once comes to the client, let's say this is client and this is internet, and let's say I have two F5, let's say F51, F52. So let's say if we have one data center, okay, in this case, if this device goes down, your traffic should not hampered. So that is how your high availability will help us to understand this. Even if one device goes down, your application should not get impacted. Maybe it can be your physical issue, maybe some issues with the switch which is connected to F51. So that's why if it goes down, your client traffic should still go to F52. So that is how high availability is configured. Even if my, let's say this is my active device and this is my standby device. If active goes down, your traffic should be capable to handle by F52. So that is the meaning of device service clustering, which means it is providing you high availability of your virtual server. So that if my primary device goes down, my secondary should be up. So that is how your deployment happens. So your F5 can be deployed in two things. Either it can be deployed on active standby, like one device would be active and one device is standby, or it can be configured with active scenario, where both the devices is capable to handle traffic. This will also handle traffic. This will also handle traffic. Let's say F51 is active, F52 is also active. But in this case, only one device is capable to handle traffic. If the one which is active would handle your traffic. And if it goes down, let's say it goes down, then only traffic will go to F52. So what does it doing it? It is providing you in resilience. So you must have heard the term resilience or 24 into 7 availability of your application. That is how F5HA is configured. Even if one of the device is got failed, another device will come up. So the partner, this is called partner device. So partner will handle your all the traffic once this is caused down. So that is how most of the deployments it's done in your data center. So let's talk about the components first of HA, how the components are configured. Then we will configure in the lab. So components, before understanding high availability, you need to understand these components. So first one is your device trust, or you can say first one is your device group. So there are three components which you need to understand before configuration of your F5. One is device group, one is device trust, and third one is traffic group. So these are the three components which you need to understand before configuring your high availability. So high availability, you have already known what is the advantage. So if someone asks you what is the advantage of high availability, what you can say? You can say that if one device in clustering goes down, high availability is considered in everything, whether Palo Alto, Checkpoint, or F5. If one device in clustering goes down, another device will handle traffic. That is what is called your high availability. This is one of the advantage. Active standby or active active, both can be configured. So we will talk on that part. What is active? So active standby, I am right now discussing about active standby. Let's talk about difference between active standby and active active before discussing components. So let's say I have active standby F5. This is F51, F52. And another scenario is active active. So what is the main difference between this? So in this case, let me draw a topology. My client is coming to internet. Then I have F51 and F52. In this case, in my deployment, I will configure one device as active and one device as standby. So in this case, my initial traffic will always go to my active. It will only handle traffic once your F51 goes down. If it goes down, your client traffic will be handled by standby. This is called your active standby scenario. This is as simple as that. Only one of the device is capable of handling the traffic. That is called your active standby scenario. But if I talk about active active, let's say I have client, then I have internet, then I have F51 and I have F52. In this case, both of the devices are active active. So in this case, in previous cases, active standby active was only processing your traffic. So this was only processing your traffic. But in active active, so it's like that both some traffic can be goes to this, some traffic can go through this. So both of the capable, like it can handle both the traffic equally, depends on your configuration. So in this case, in active active, both of the devices are capable of handling traffic at the same time. So in this case, when we talk about traffic group, I will discuss what is the difference. But in this case, active active means both are active, both are capable. Some traffic can goes this way, some traffic can goes this way. But most of the deployment is done on active standby. That is how the deployment is done. Now let's discuss about the components. So first component is device group. So whenever you configure your HA, you need to configure your device group. So device group is nothing but let's say I have device A, which is F51. I have device 2, which is F52. So this combination is called your device group. So collection of F5 devices in HA is called your device group. So before doing proper configuration, you need to first configure this step device group. So in each device group has some certificate which is exchanged between both of them to build a trust with each other. So it's easy. By the name, we can say device group. Group means combination of, or you can say collection of F5 devices. So when I will show you the deployment, you will first configure your device group. So device group is a combination of devices which you need to take care. And this combination is called clustering, or you can say cluster, where each devices will share their configuration. So people have question, if I configure something here, let's say I configure virtual server here. So let's talk about active standby. So people have question like I have F51, I have F52, both are connected to my. So in this case, one is active and one is standby. So people have question, do I need to do configuration? Like configuration can be a virtual server or it can be your pool, other things. So what are the configurations which will be getting synchronized? So that is an important question which was asked. So active means I need to only do configuration here. I don't need to do any configuration on standby. Like any configuration related to virtual server, pool, or profiles will only get configured on F51. You don't need to configure your virtual server, your pool in VS2 or F52. When you synchronize, it says configuration synchronize. All the changes which are done on F5 will get synchronized on F52 automatically. So this is very important term. So that is how it done. So that is how device group is built. So device group is a combination of multiple F5. Generally in active standby, this is how deployed. Now the next component, both of the devices, I will show you how to add it. So this will in device group, first condition will be both of the devices should trust each other. So they do trust each other based on your certificates. So how F52 will trust F51, how F51 will trust F52. That is called your trust. So we will come across how to build a trust. But this is the condition. So these devices and device group should share the certificate to build a trust so that they can exchange your configuration. So that is an important concept. So there are two devices group categorization. So in device group, if I come across device group is also categorized into two things. One is called sync only and one is called sync failover. So these are the two components which comes under device group. Sync only device group, what does it mean? Sync only device group will only synchronize your configuration data. That is all. So let's discuss more on sync only. So what is the difference between sync only versus sync failover? So let's say sync only will only it does not support failover. First of the condition is it does not support, you cannot failover from one device to another using this if you have configured sync only device group. So F5 only prefer you to configure sync failover, but sync only device group contains it only synchronize whatever you configuration you do on one device, it will synchronize to another, that's it. So it will synchronize only configuration data. So that is why its name is sync only. It does not support failover between the devices. So that is all configured between this. But my logic would not here configure, right? I want my client, then my internet, then let's say I have two F5, F5 2, F5 1. I want, this is my active, this is my standby. I want all my configuration which is done on this get synchronized also. Okay, first thing is I want synchronize. Like I want same configuration on both the devices. First task is this. That's why failover will happen, right? If one of the device has different configuration than second device, then application outage would happen. So first thing is I want to synchronize all my configuration. Second thing, if this device goes down, I want to failover also. So I want to configuration sync also, and I want to support failover also. So that is my main purpose, right? I want to support failover between devices. And I want same configuration to be there in this device and this device. So in this case, what is the concept they have introduced? That is called sync failover device group. So that is very, very important. People will ask you what is the difference between sync only and sync failover. So in case of high availability, we only use this sync failover device group. And in this case, you can configure 8 devices combination. Like in production, I have not seen that we can use 8 devices or 9 devices, but there is a limitation. You can configure 8 F5 devices and sync failover device group. When you configure device group in F5, generally you use two only. One is active, one is standby. But maximum limit is it can support maximum of 8 devices. So that is how it is configured. So let's say if I can need to configure device group. So before configuring device group, we need to first configure. There are two concepts. One is config sync and one is failover address, which I will show you. Because I need to configure one IP which will be used to config sync and one is for failover address. So failover address is an IP address that is used for your network failover or serial failover. We will talk about this. And config sync is basically used to configuration synchronization. So we will see. So now let's talk about another component of F5 which is called, we have talked about device group. Now let's talk about traffic group. So what is the advantage of traffic group? So traffic group by name is, you can only see it's all related to traffic. So traffic group will determine, let's say first thing is it will determine how traffic needs to be forwarded. Who will handle what traffic? So that is all handled by traffic group. So determine how the traffic needs to be forwarded to the devices in device group. So by definition, you can understand because F5 has given all definition clearly. So traffic group is a combination where it will tell how the traffic needs to be forwarded to the devices in device group. So another case, what traffic group take care is, this is the one, it will ensure that when active device goes down, all my objects, all my failover like virtual server should go to standby device. So that is how your traffic group is. So one this device, this concept will ensure that when active device goes down, all my failover should go to my standby device based on your device group. So let's say we have one device which is called F51. We have one device which is called F52. So every device has by default one traffic group which is called traffic group 1 here, and it also have one traffic group which is called traffic group 1. So whenever you install F5, by default both of the devices will have traffic group. So in this case, when you configure in HA, only one traffic group will handle at a time. All other devices will be in standby. So let's say now I have a requirement where I have to build HA. So I have client, I have internet, then I have F51 and I have F52. In this case, at a time only this traffic group will be active. So let's say this has traffic group 1, this has traffic group 2. So only at one time traffic group 1 will be active, and this will keep on monitoring. Once it goes down, it will keep sending the timeouts and everything. So in this case, when traffic group fails over to another device in the device group, that will become now active. So that is all the combination of traffic group. So traffic group generally is determining if it will ensure that if this traffic group goes down, it will handle the traffic. And it is a combination of your device group. So traffic group, once I will show you traffic group is a combination. So it will, so when you configure traffic group, you will see all your virtual server under this. You will see all your pool members under your traffic group. Device group was only a combination of devices, right? That's all. So device group was just I added two F5 in device group. That's it. But this is what will handle all the traffic. So at a time, one traffic group can be active. So it will determine how the traffic would be forwarded into device group. So that is very, very important. So now let's talk about something related to device trust. We have talked about traffic group. We have talked about device group. Now let's talk about one more component which is called device trust. So configuring HA is not difficult in F5, but you need to understand this term. So device trust is representing your trust relationship. So before configuration, your F5 in HA, you have, like I have F5.1, I have F5.2. This short, this both the boxes should trust each other. If they don't trust each other, your configuration will not get synchronized. So before configuring your device group or traffic group, there should be a trust relationship between both the devices. So this can be achieved using certificate based authentication. So if someone asks you like how one device in F5 trust another device in HA, so you can say they uses certificate based authentication. That is very, very important. So this is a prerequisite. So device trust is a prerequisite to build device group and traffic group. If trust is does not build, then your devices will never come in HA. So this is a prerequisite. So now this is about the components. So we have discussed three components which are very, very important. So first component was device group. Second was traffic group. Third was device trust. So we have discussed this, how this is a part of this. Now let me talk about when you configure your device group, we talked about some configuration which was related to config sync, failover address. So let's talk about my lab topology now. So what we will do is, now let's talk about our production or lab topology, how F5 is deployed in production, and we will discuss more concept here. So let's say I have client, then I have F5.1 and I have F5.2. So what are the consideration? So I will configure one device as active, one device as standby, and I will build device group, device trust, and traffic group. So these three we will configure it. So before that, you need to understand that in your network topology, we will have one dedicated HA VLAN. So we say when we talk about lab topology, let's say we have client and both are connected to F5.1 and F5.2. So in this case, first configuration, which is very, very important, is network configuration. You need to first configure your network settings. So in production, what we will do, we will have one internal VLAN, let's say, because in our topology, we are using two VLANs so far. One is internal, one is external. So let's say in internal VLAN, we have configured internal VLANs as 20, 10, and external VLAN as 20. So one IP of 10 would be assigned here. Let's say external VLAN, my internal VLAN is 10. So let's say I will give one self IP as 10.10.2.2.50 here, and here I will give 10.2.51. So whenever you configure your HA in active standby, your any of the VLAN will have three IP address. So let's say I have internal VLAN. My internal VLAN in my topology, I'm using 10.2.2.0/24. Okay, I have F5.1 and I have F5.2. So in this case, suppose you do not manage your network team. In this case, you will ask your network team, hey, I need three IP addresses. I need three IP address for internal VLAN. Why? Why we need three IP addresses? So now here the term comes under that is called your floating self IP. So we have configured to one IP address so far, right? One IP address here for internal and one IP address here. So we will have three IP address. One is, let's say, 10.2.2.50 here, 10.2.2.51 here. Okay, these are the two IP addresses, and that third IP address is called floating. Okay, so what is the difference? But what is the main thing which is called floating? What is floating? Let's first understand what is floating self IP. So I talked about like I have internal VLAN. Internal VLAN will have three IP address. Then I have external. External will also have three IP address. So why three IP address? Because first IP address for active, one IP address for standby, one IP here, and one IP here, and one IP is floating. So that is how you configure three IP address. Same is the case with external, one IP active standby, and one is floating. And we have another topology, another VLAN in my production or my lab. I will be using dedicated VLAN for HA. So let's say for HA I'm using 30 VLAN. In that case, do we need floating IP? No. In that case, we need only two IP address. One is for active and one is for standby. That's all. You need to understand this thing. Floating is only needed in internal or external. But in HA configuration, floating is not needed. Because HA is just a dedicated VLAN which is assigned. We don't need to do any config sync or something. Because your VS would be part of external, your pool members are part of internal. HA is a dedicated VLAN, that's it. VS or pool members or any configuration of local traffic would not be a part of HA. That's why we don't need floating IP address here. So now we were talking about floating. This is very, very important. So when we do network configuration, there is a term called floating self IP in HA. This will only come when we talked about HA. So floating self IP is nothing but it's a for every VLAN I will be creating this, which means this will be same IP address which will float between F51, F52. This will determine which IP is active, which is down. So in this case, whenever you configured, so floating self IP, first of all, everyone has a confusion here. What is self IP and what is floating self IP? So self IP is clear, but in this simple term, if I talk about, this is same as HSRP or VRRP, virtual IP address. So if someone has confusion or they have done switching, so floating IP address is just a virtual IP address that is configured on your F5. So it will be same. It will be same in both F5. And it will be assigned to traffic group. So floating self IP is the, because see, let me tell you, you have client, you have F51, you have Let me draw it properly. Let's say I have client, then I have F5.1, I have F5.2, then I have some backend server. So let's say I have this way. In this case, can your backend server, because one device is active, one device is standby. Question is, what would be the gateway? Let's say when I have two F5 in HA, what would be the gateway of backend server? So guys, if I do two gateway, then how backend server will know which one is active? So in this case, my backend server gateway will be always floating self IP. So that is how. So floating self IP is only one IP address which will initiate the traffic to backend server. Because you cannot give two gateway, right? Because one device is active, one is standby. If I give two gateways, this server will get confused. Should I send traffic here or should I send traffic here? That's why whenever you give floating self IP, it is same, and that will be the gateway of your backend server. So that's why the concept is come virtual IP address. Floating IP is virtual IP address. That is one IP address. So this was important, so I wanted to tell you. Now let's talk about topology. I have client and I have F5.1. So first of the case, both when you configure F5 in HA, both F5 should have same OS. So in when you are doing HA lab with me, you need to take care. Let's say if it is 12.1, this should also run 12.1. So that is what I'm running in my lab. This is an important concept. Second thing is, let's say if this is provisioned for LTM, it should also get provision for LTM. If it is configured for LTM and ASM and it's configured for LTM, your devices will not come in HA. So this is the prerequisite. Your F5 should have same operating system and they should configure license for same modules. Like if this has LTM, this also should have LTM. So that is what I have configured. Another configuration which we need to take care, I will configure one dedicated HA VLAN, which I will assign to 1.2 interface. In my lab, I have configured 1.1 as external and 1.3 as internal. So I will configure 1.2 as dedicated HA VLAN. So let's see and configure our devices. So I will go in my lab setup and I will show you how we build it. So you can see step by step. So first of all, let me show you. So when you go, I have this F5. I will show you what are the configuration I have done in both the F5. So see, I have using same interface. One is Vimnet 8, which is my management IP address. I'm showing you VMware configuration first. Vimnet 8 is my management. This is my external Vim bridge 1. Vimnet 1 would be my HA and Vimnet 2 will be my internal. You can take the snapshot. This is very, very important, guys. Please note down this step by step. We will configure everything in HA by this way. So the same thing I have configured in my another F5. So this is the same configuration I need to configure on HA2 device also. So I will delete this. I will show you another one. So see guys, Here also I have configured management, I have configured external, and Vimnet 1 I will be using for HA, Vimnet 2 I will be using for internal. Okay guys, now let's come into our F5 box. So I have two F5 box in my thing. One is this one, which I have given IP address 137.50. Second one I have given 192.168.137.51. So how to see the version, which version my F5 is? You need to go to system and you need to go to configuration. So here you will see the version of your F5. So you need to go to system tab, then configuration, then device. This is the version. So version mismatch should not happen. Version should be same in both the boxes. So this is HA2, F52, and let me go jump into F51. So I will show you what is the version it's running. So see, this one is also running 12.1.0, and let me jump into the another one. This is also running. Can you see this? Both the devices, this is the pre-request. Whenever you build an HA, both the devices should be on same operating system. So please note down this step. This is very, very important. Both the devices should have same operating system. And you can go to system, then you go to configuration device general. You can take the snapshot if you want. Now let's come into another. Now we will configure your network setup. So another prerequisite is license of same module should be there. Like if I configure LTM on F51, I can configure LTM of F52. If both have different modules, F5 will not come in HA. Okay guys, so let me show you that how we can see that. So I will go to system, resource provisioning. Can you see this? This module is configured only for LTM, nothing else. ASM, GTM, nothing is there. Let me come into big IP one. This is also configured in nominal mode, only LTM. Can you see this? Both the devices, both have LTM1. So that is the pre-request. If this is not the case, your F5 will not come in picture. Now let's talk about. So guys, we have discussed two prerequests. One is we need to have a same module, same model. It should use same software version, and it should support resource provisioning same LTM. That is a prerequisite. So now let's configure network topology. We have to configure three IP addresses, correct? If I talk about network configuration, we have configured same version. First one is done. Second one is we have licensed the boxes for both LTM. Third one is network configuration, where I will use configure floating and we will configure dedicated VLAN for HA. So I will be using dedicated VLAN for HA. My HA VLAN would be IP address 10.1.0/24. So in my LAN topology, lab topology, let me draw the table so that it would be easy for you. I have one VLAN. Let me draw the table for you so that it would be easy. Then I have network, subnet. Then I have interface. Then I will configure self IP. Let's say it is LTM1, self IP, LTM2. Then we will configure floating IP. Just it's little bit. Let me draw from here. VLAN, your network subnet, your interfaces, guys. You can take the snapshot of this so that it will be easy. Self IP, LTM1, self IP, LTM2, and floating IP. So I'm using three VLANs. One is internal, one is external, and one is HA. So my internal VLAN is 10.2.20/24. My external VLAN is 192.168.1.0/24, and my HA VLAN is this one. So we are talking about network configuration now. And my interface of internal is, let me go and show you what is the internal interface which I am using. Just verifying it, network interface. So 1.1 or 1.3. Just give me 1 minute how I can verify. I will go tab here. My Vimnet 2 MAC address is 6B37. Okay. 6B. Okay. 1.3 is my internal. 1.1 is my external. And HA would be 1.2. Management. There is one more VLAN which is called management. You can just ignore it. This is how it is. What is the IP address which I have configured? Self IP. I have configured on big IP 110.10.50. This is .51. And floating I will configure .52. What is my external self IP? I will go and check it. I will go to self IPs. Okay, this is 1.51 here. Okay, 1.50. So here I will configure 1.50. This is 51 and floating would be 52. What would be the HA? HA does not hit any floating IP. So in this case, I will configure one IP as 1.50 and 1.51. Third subnets would be same. 3 bits would be same. So 10.1.1.50 and 1.51. Floating is not needed. So let's configure this way. You can take the snapshot, guys, if you want. Now let me jump. So see, we have configured self first interfaces. Let me go now into my VLAN. I will configure my HA VLAN. So I will give name HA and I will say untagged 1.2. So I have configured three VLANs. Can you see this? One is HA, one is internal, and one is external. And this is my interfaces. And I am using dedicated VLAN for HA. For HA, I am using 1.2. Okay, it's a dedicated VLAN. I'm not using HA from management or internal. I'm using, I want, because in production also we should keep dedicated VLAN and self IP for HA. Now let me configure my self IP. So see, I have configured external self IP 1.50, internal as 10.2.2.50. Now let me configure my HA VLAN. So I will say HA self. IP address I will give 10.1.1.50. Netmask slash 24. That is all. Port lockdown I can give allow all. Can you see this traffic group is local only? I will show you. This is what I was talking about. One is traffic group non-floating and floating. Because HA does not need any floating IP, so I will just finish it. So I have given 10.1.1.50. Now let me go to big IP2. I will create one dedicated HA VLAN, which I will say, let's go here and verify HA, and I will give 1.2. So we have configured HA VLANs on both the devices. And I will see what is the self IP. So I will give go to self IP and assign HA self. I will give IP address. What is IP address I've given on primary? 10.1.1.50. Here I will give 10.1.1.51. I will give subnet mask and I will say allow all. That's all. So now we have done basic network configuration for both the devices. We have configured interfaces, we have configured VLAN. So far what we have done is we have configured interface, then we have configured VLAN, then we have configured self IPs. So this task we have done. Now another task is we need to configure internal and external floating self IPs. So we have to give one floating IP for this, one floating IP for this on both the boxes. So let's see how to configure floating self IPs. So guys, when I go here in external one, when I click here, can you see this? It's assigned to traffic group local only, which is a non-floating IP. The same way I will configure one IP address, which I will be configured same on both the boxes. So what I will do is I will jump into that. So I will give external floating. I will give IP address 192. First, I need to verify what is the subnet. So I will get 1.52. External floating. IP address I will give 192.168.1.52. Net mask 255, 255, 255.0. Here I will say external. Here I will say allow none. And I will give traffic group floating. That's all we have to configure. That is how we configured our floating IP. I will finish it. Same thing, I need to go here and configure the same way. So I will give external floating. I will give IP address same because floating IP needs to be configured same way. 1.52, 255, 255, 255.0, external, allow none, and here I will give floating. Now one thing pending is we have configured floating IP for external, we have to configure for internal. Now we will give internal floating. IP address is 10.2.2.52. Net mask is 255.255.0, and I will say internal, and here I will change it to floating. Same, I need to go and configure it for big IP2. 10.2.2.52, 255, 255, 255.0. So internal I can say allow all. Here also allow all. So I have external none, and what internal routing allow all. Here also I'm giving allow all. So I will just now verify what are the self IP. Are they same in both the boxes? So we have 5 self IPs here. 1, 2, 3, 4, 5. We have configured floating for internal and external. Same, it should be there. 192.168.1.52, 1.52, 10.2.2.52, 10.2.2.52. And we have configured HA. So we have configured this. Now we have done with the network configuration. Now other task which we need to do is we need to configure config sync and failover. So before building, like we talked about device group, before building device group, we need to configure 3 IP address. One is for config sync, which will help you to configuration of your devices, then failover IP. So let's go and configure our HA now. Now that we have done with network, we have done with licensing. From here, all the things would come under HA. So I will go and go to device management, devices. In both the devices. So all the HA configuration would be done here. So can you see this? We have 3 things: device group, device trust, traffic group. The same thing would be present in another device. So I will delete this and I will go and go to devices. I will go here. Here where I need to so I did devices. I click on bigip1.com. So here I need to give all. So config sync, failover network, and mirroring. So I need to give config sync. Which VLAN would be used? So what is this? So config sync is basically this VLAN or IP is used to sync your configuration. So this will help you to sync your configuration objects to other devices. So I will be, since I am using dedicated VLAN, so I will give HA because I have used this because HA is a dedicated, and this address should be non-floating IP. So I will say this one. The same thing I need to do here. Config sync, I will select HG. And this should be non-floating. Now I have given config sync. Now let me configure the failover network. Another thing is failover network. So let me delete this. So guys, failover network, we need to configure it. Failover network will decide, like let's say, what is failover network. So failover IP would decide how to failover. In this case, let's say I have F5.1 and I have F5.2. How F5.1 will say that this is down? So this is where this IP will help. So can you see this failover unicast? So it will keep pinging. So if it sees that it caused timeout, then it will fail over to secondary device. So that is how. So this IP is for health assessment. So you can say this IP is used for health check. So I will just delete this and I will configure it. So in this case, what I will do is, in this case also I will add, I will use HA. Can you see this? This is the port number which is used. So in this case, I will add this. I will to configure two things, two unicast, one management. So suppose your box goes down, your internal VLAN goes down, still it can able to ping another IP address. So that is how it is configured. Your management will be still up, right? If there is an issue with your switch, where external or internal VLAN is, that's why I'm giving two IP address. If both the devices health check failed, then only it will get failover to big IP2. That is what is there. So now the same thing I will configure on this. Failover network, finished. I'm using two unicast address. Then I will use HA. So I have given two IP address. So this is also important to prevent any, like one is active, one is standby. So split brain issues can also happen, right? So that's why I'm giving management also split brain to avoid split brain issues. Sometimes we say F5.1, F5.2. Both the devices thinks that they are active. So to avoid this, I'm using management unicast so that if this IP makes sure that this IP goes down, it's still able to ping through management. So I'm using this as a heartbeat. So you can say failover network is used as a heartbeat. That's all. Now one thing more is there, mirroring. When I go to mirroring, so mirroring is basically to mirror the configuration. Same configuration should be present on my active box. Let's say I have a persistence profile. So I want same connection to be replicated on both the boxes. So in this case, I use mirroring concept. So there can be mirroring persistence or connection mirroring. So what I will do is I will use one as HA and one as internal. Same thing I will configure here. HA internal. Now what we need to do is we have configured this. Now we will build device trust. So I will go here. So can you see this? Both the devices has certificates. So that is how authentication is built. This also has certificate. If I go here, this also has certificate. So I will go here and go to the peer list. Here I will go and I will build a device trust. So I will here mention remote device IP address. My remote device IP address is 192.168.137.51. Admin username is admin. So if all things are okay, it should show me. So can you see this? By default, when I retrieve, let me do cancel here. I will go to device trust and I will add this and I will add IP address. That's all I need to do. Admin and I will retrieve. So see, by default, management IP address is detected and certificate is there with SHA-1 serial number and it's saying that signed, certificate is signed. So I will finish this. It means your device trust has been built successfully. Now let me go here. Here also. So can you see this? By default, when I go to big IP2, it has built a trust. Now let's go into device group and I will add devices. I will create sync failover devices and I will give them name device sync fail device. So I'm building. So see, can you see this? Both the devices I need to add big IP1 and big IP2 because it's a combination of both the devices. So I will select this and I will select this. And can you see this? Now I need to show this. So people have question like how one device will detect whether second device is down or not. So here there is an important concept which come in the picture is failover. How one device will detect. So there is a concept here it is called. There are two types of failover. One is network failover and one is serial failover. So what does network failover means? This is important with interview versus serial failover. So network failover will use heartbeat to determine if one device is active or not on another device is down. So what and in serial failover it will be using. So let me discuss on diagram. This is important one. So let me give 2 minutes to it. So we have failover, network failover, and one is serial failover. So network failover, let's say I have F5.1, I have F5.2. In network failover, this will keep pinging each other. Heartbeat detection is done using IP address. So it will keep sending ICMP request and ICMP echo. So heartbeat packets are transmitted over network. That is called network failover. But in hardware failover, serial failover, you will send a voltage. So in this, F5 1, F5 2. It will keep send voltage. And it will be used when you are using any physical. So both the devices should be placed in 50 meter. I cannot place this, I cannot use serial failover when one F5 1 is placed 100 meter away with F5 2. So there is a condition in serial failover where the continuous voltage check would be done over special cable to determine if one device is up or down. So they should be closer to each other. So serial failover can be used only when F5 1 and F5 2 are 50 meter from each other. Suppose F5 1 is in data center 1, F5 2 is in data center 2. I cannot use serial failover. In that case, I need to use network failover. So that is all what I wanted to tell you. Now, once I did this, let me go back into the configuration. I will use network failover. And can you see this automatic sync? Automatic sync, whatever I do, changes on one device, it will get automatic sync. But I don't want that. I want manual sync. So I will just finish it. So now I will go here, device groups. Can you see this by default? All the things. So can you see this? This device is active and this device is standby. So I have configured device group, device trust, and let me show you traffic group now. So traffic group, can you see this? You will see all the things which are floating here. And when you go here, it will determine which one is active and which one is standby. And one important concept more is available, which is called failover method. Which failover method you should use? So in this case, what generally happen is either you can do load aware, like whichever has less load will become active, or generally in production environment, generally it is done like this. So I will add this. I will select HA order and I will update. HA order means this one will be up, this one will be second one. And I will configure it here also HA order. So see guys, now I did some changes and it's showing that changes pending. So it means our HA configuration is completed. HA order means failover order. First it will fail over to this, then it will go there. This will be primary and this will be secondary like this. Now if I need to config sync, let's say I will go here, how to config sync. If I have done some, I have created some virtual server, okay? Or I have done some changes on this device which is active. So one thing you need to take care whenever you are in production, you will do all changes. All changes needs to be done on active. Then you will do manual sync. You will go to changes pending and you will select this device group. How to config sync? Like I want to sync all the configuration from this device. It should automatically pop up there. So what I will do, I will click here. I will go click on this. I will say sync device to group. Whatever changes it's there in this device, it should populate into my device group, and I will overwrite all the configuration. So this is how I will be doing configuration changes. Same configuration will come there. Let's see. Whatever virtual servers pool members are there in this device, it should populate on both the devices. Let's see. So can you see this, guys? It's saying that in sync. Let's see. Whatever virtual servers I've configured here, it should present in there. I have two virtual server here. Let's see if it's there on my big IP one. Can you see this, guys? I have not configured anything. Did I configure any virtual server? Because I had one device where configuration was there. The same configuration, I did config sync and everything is populated on big IP1. Now let me create new virtual server, or let me create one pool. What I will do is, let me change some settings. I have pool of 3. I will add one health monitor. Suppose I have a requirement, I need to change one health monitor of pool 3. So I will update this. That let's see if same will be populated on another one or not. So guys, can you see this? Whenever you do changes, it will show you changes pending. I will not do sync now. Let's see if same has been populated here. I'll go. So guys, can you see? Here HTTP is not there. Why? Here HTTP is I have added. Here it's not there because I need to manually sync it. So I will go to changes pending. Then I will select here and I will say sync device to group. Let's see if it gets sync or not. I want same configuration what I did on active to be on standby. It takes sometimes time due to the lab. So let's give it time. It's taking some time. Let me do one thing. So guys, I did wrong thing, right? I need to select big IP2 here because this is my big IP2. Now let me do it. So guys, you need to take care of this. If you are on big IP2 which is active, you need to select this. Now let's see if we have, let me refresh. We should have HTTP. Can you see this? We have HTTP now. So this is very, very important. You need to do manual sync because I did not select it automatic sync. So if you are on big IP2, if it's active, you need to click here, then sync device to group, which means whatever configuration there is in this device, it should populate to my device group because device group is a combination of both the devices.